Problem number 12. An air-filled parallel plate capacitor has the capacitance of 2.1 picofarad. The separation of the plate is doubled and the wax is inserted between them. Now the new capacitance is 2.6 picofarad. Find the dielectric constant of the wax. Here in these questions we have two parts. In the first part, you did not place any insulator between the plates because in between the plates you have only air, that means space, right? But in the second part of the question, you have the capacitor, but in between the two plates, you are going to insert a wax material. What is wax? Wax is an insulator. So what we studied in the theory, when you kept an insulator between the two plates, it will increase the efficiency of the charge which is stored in the plates, right? So now what is our final answer here? What is the value of the wax, the dielectric value of the wax? Actually, the dielectric value of the material is a unitless value. There is no unit for that. Clear? So now we are going to find what should be the dielectric constant value for the wax. So better we can do one thing. We will draw the diagram. By that, we will get a clear idea. So in the first part, what they give, you have the air-filled parallel plate capacitor. What is the meaning for air-filled? So if you see this diagram, you have two parallel plates, but in between the two parallel plates, only air is there. So when you have the air-filled parallel plate capacitor, by the time, what should be the capacitance value? You have the capacitance value of 2.1 picofarad. Now what is the distance here? The distance here is d. So this is the first part. But in the second part, what you did, you increase the distance between the two plates. So what will happen? Your diagram will come like this. You increase the distance between the two plates. But what you did, you are going to insert the wax. So when you insert the wax here, what will happen? It will increase the charge which will be stored. You can see the value. In the first part, you have the capacitance value of 2.1. But after you insert the wax, what is your capacitance value? Which is 2.6 picofarad, right? So how we got more capacitor, more charge, more capacitance here value? Because you insert the wax material. Whenever you kept the insulating material in between the two plates, it will increase the efficiency of the capacitor. So now, what is the distance here? The distance here is 2d because we double the distance. Now I am going to apply the rule. As we already know, the formula for the parallel plate capacitor, which is epsilon naught A over D. I'm going to use that formula for both first part and the second part. So let's see what is the answer. So capacitance for the first part is C, which is equal to epsilon naught A over D. And here the capacitance value is given. So what is the value of the capacitance here? The value of the capacitance here is 2.1 picofarad. What is the value of the picofarad? 10 to the power of minus 12. So I can just write 10 power minus 12 farad. And likewise, I have to apply the same rule for the second part. When you apply the same rule for the second part, what should be your equation? Capacitance C, which is equal to, so we insert the wax material. So we have to introduce a dielectric constant K. So here K is nothing but the wax value. Multiply with epsilon naught A, but what is the distance? The distance is double. And once you just place the wax material, what should be your capacitance value? 2.6 picofarad. So 2.6 multiply 10 power minus 12. So let's we take, this is our first equation, this is our second equation. Now we are going to find the answer for the K. So what I'm going to do, I'm going to divide the second equation with first equation. So when you divide second by first, what you will get? So divide 2 with 1. So second equation is going to divide with the first equation. So first of all, I'm going to divide the left hand side of the equation. So K epsilon naught A over 2D is going to divide with the left hand side, right hand side of the first equation. What is that? Epsilon naught A over D over D. Now I have to divide the left hand side of the equation. What is the capacitance of this? the capacitance value is 2.6 multiply 10 power minus 12. Likewise, the left hand side of the first equation is 2.1 picofarad. So I have to use this value, 2.1 multiply 10 power minus 12. So let's rearrange this equation because this is in the division form. So when you just rearrange this equation, how your equation will change? K epsilon naught A over 2D multiplied with the D over epsilon naught multiplied by A, and here you can cancel this pico, so therefore you will get 2.6 over 2.1, right? And here also we can cancel epsilon naught A, and here also I can cancel this, and I can cancel D with D. So now what is remaining in this equation? So the information which is remain in this equation is K over 2, which is equal to 2.6 over 2.1, right? So K, which is equal to, so this 2 will come to the right hand side of the numerator. So 2 multiply with 2.6 divide with 2.1, and that will give the answer for the K. So K, what is K? The K is the dielectric constant of the wax, because we kept the wax metal in between the plates. So let's see what will happen. So the value of the K is 2 multiply with 2.6 divided by 2.1. Here I got the answer as 2.476. What's the value of the dielectric constant of the wax? 2.476. It's a unitless parameter, so you no need to put any unit. Okay, just leave the number as it is. So K, which is equal to, if you want rounded the number to 2 digit, no problem. Okay, so the answer for the dielectric constant of the wax is 2.476. So this is the answer for this question. That's it. Thank you.